he has been doing work in sustainable mining, management of continuous and integrated mine closure, cemented paste backfilling, surface water impacts of mine waters, and environmental impact and risk assessment of mining projects. So Tommi, welcome, and the floor is yours.
Thank you, Saku, for the introduction. The introduction listed some very detailed approaches of how you make mining more sustainable and environmentally friendly, but now we are looking at the GTK level. Like, what is GTK doing to support all this? Like, how do we get these raw materials for this transformation that Simon talked about sustainably? Now, this first slide shows how what was already shown in the GTK strategy slide shown by Kimmo, that we have identified these pressures and need for systemic changes and inserted them in our strategy. Because what we need, it's clear, we need less mining waste while we're mining, less negative impacts, less CO2 emissions, and less lost materials, while we need more to secure more resources for future generations if we are going to use so much of these resources ourselves. We need sustainable production of raw materials from both primary and secondary sources. We need to trace what we are mining and producing sustainably, and we need circular solutions to keep this in the economy for as long as possible. And how does a geological research organization do all this? We do it by research and innovations, and this data collecting. We actually need to look at the rocks and collect and distribute the data. And we do it together with the industry and the society and the scientific community to reach our goal, which is this sustainable carbon neutral future. And if we first look at the data, this has been our core business for 140 years, because the availability of future mineral raw materials for future generations and ourselves as well is based on exploration, but also research. And this can only be done not only by us, but with an industry, geosurvey, academia collaboration. So we need these high quality geological information on both primary and secondary raw materials. We need to provide it in a harmonized way with an easy access. So we actually need to do this geological research and data collection, enrich it with things like geophysics and geochemistry and environmental observations. We are running a drill core archive to be used in these studies and to, let's say, store the results of previous research. We also study how these resources can be processed sustainably at GTK Mintech. We do that, and then we collect and manage and distribute these data. Now, who uses these data? And then first, these are let's say the raw materials and deposits for future generations to use. So it's our responsibility to keep on doing this kind of data collection. It also, let's say, attracts more exploration activity, this private exploration activity to Finland, and this in turn, it increases the stocks of these information and these deposits for the future generations when we collect and manage and also distribute the results of this exploration activity that we attract by these data. And then finally, these data can also be put to good uses, because like Simon said, we need these, let's say, wise decisions need to be made. So these data can be used for sectoral governance and resource management, not only in Finland, but throughout the EU. And we also have a minerals intelligence arm to enrich these data and to support intelligent or well-informed decisions in the minerals sector. And finally, it's important that we also consider the secondary resources related to these ores and deposits, and because we'll need to support circular business models around the minerals, and we are working on that as well. And one of the tools, this is a new thing. GTK can now present Finland's primary mineral resources in the UNFC code. That you see the principle there on the right. It not only looks at the geological factors, but also the technical feasibility of exploiting that deposit and the economic and environmental feasibility of that. And this kind of a harmonized way of presenting things is really important for the decision making and builds a stronger security of supply, not only in Finland, but in the EU. And we are currently in the process of extending this to secondary raw materials as well. Then we are actually in a good phase in this development, because we are mining non-renewable raw materials, and the theory of sustainable mining says that these raw materials should be put in sustainable uses and to produce durable goods. And green technologies provide an opportunity to utilize these minerals sustainably. And in fact, GTK has work ongoing in several areas of these green technologies. We are looking at battery minerals and their traceability. We are looking at minerals for other renewable energy sources. We are supporting offshore wind power construction. For decades already, we have looked into safe nuclear waste disposal. We have a very strong geoenergy arm at GTK. We have looked at CO2 capture and storage, and we are very much looking to design out mining waste to produce mining waste-based products. And all these good things, from the sustainably mined deposit all the way to these good uses, should be traced. So the materials we use for the green transition, they must be demonstrably produced in a responsible manner, and these responsible origins should be traced throughout the value chain. And GTK is developing methods in several projects for metal traceability. We are using fingerprinting based technologies, and these are used then to complement these digital ledger based methods. Finally, I would like to draw your attention to GTK Mintech. GTK Mintech, as many of you know, is this our global research and innovation platform for sustainable mineral processing and circular economy. And when we say platform, we mean that everyone who has an idea is welcome to work with us there. It's based in Outokumpu, Finland, and it has this value chain or research chain that you see on the right, that starts from detailed and automated process mineralogy, goes to the benchtop process testing, finally to the pilot plant size testing, then looks at the circular economy aspects of all this and valorization of the waste, provides data for the waste management and water recycling and water treatment. And you see there on this aerial photo that we are building a new lab building there. We are also in the process of updating our tailings facility. And on the right there, where the trees now are and the power line, there will be our new mining waste field testing facility constructed next summer. So everything from the ore deposit to mine closure is provided by us, or we are looking into it. So from the mineralogy to bench scale to pilot, and we have developed it as a center for co-creation. So there are spaces for you to work with us there, so everyone who has an idea is welcome. We can start from the deposit by looking at the geometallurgy of the deposit, and we will then provide this with the design these low impact process design routes. We are looking to design out mining waste, but we need help with that. So we need people who have ideas of what to do with the minerals in the mining waste. We will provide this long-term waste testing facility starting next summer, hopefully. We have facilities for process water recycling research and water treatment, and we are strong, or have been traditionally, looking at the remining of old mining wastes, processing secondary raw materials, and we have run many projects with these innovation metals that are needed for this transition that we are talking about here. So in summary, we run projects in all key areas of sustainable mining and minerals production. This is not an ad hoc thing. These approaches are built in our strategy and have been there for a while, and they stem from our role in the society. It's important to understand that sustainable mining can only be carried out with the combination of private and public efforts, and this is the domain where we also work. And the green transition, it's an issue that calls for global solutions and global responsibility for all regions, including Finland, because the resources are not distributed evenly. Thank you.
Thank you, Tommi. So we can say that we are actually doing a lot of very practical things to improve the current situation. But now it's time to hear our guest speakers. First, we will give floor to one of the very central persons in European Commission when it comes to the minerals and metals. Peter Hanley is the head of Energy Intensive Industries and Raw Materials Unit in the European Commission, Directorate General for Growth. He has previously been a head of the Resource Efficiency Unit at the Secretariat General, where he was responsible for coordination of Energy Union 2030, Climate and Energy Package, Low Emission Mobility Strategy, and the Circular Economy. So, Peter, please welcome. Floor is yours.
Yes, good morning. Very strange lighting on me here. I've listened with great interest to both of the last speakers. Now, what strikes me from Simon's work and the report that's been presented today is that it ties in very much with the thinking that we are developing in our critical raw materials impact assessment, which is, we know that it's going to be a very hard sell to convince the public that demand for critical raw materials and other raw materials is going to rise by 5, 10, 50, whatever multiplier you like, unless we can demonstrate we've really done the analysis very thoroughly and looked at ways in which we can meet society's needs and suppress demand as much as possible. So we've got the JRC looking at this aspect for us, and I think that the work that you're doing on, plotting the different scenarios for the energy transition and coming to the conclusion that there's just not enough stuff to make it possible for everybody everywhere in the world, I think it's quite an interesting one. And then what we just heard from Tommi is music to my ears, actually, because the kind of expertise, the all-round expertise that you have there in GTK is precisely the kind of building block that we see forming part of an integrated European capability on minerals intelligence and actually minerals action. So, we think that we can't just carry on the way we are. We have some very nice, very useful expert groups already, the raw materials supply group being one, and the European Innovation Partnership on Raw Materials another. But these are essentially consultative groups, and their role is to advise the Commission on policy. And one of the core conclusions we've already come to is that we need to have some operational capability at European level, which can do the kind of job that JOGMEC does in Japan, or the very similar agency that Korea has. That's to say, an organization which can really track everything that's happening, which can anticipate supply chain disruptions, can do foresight work, but then can actually be very much involved in identifying strategic projects and delivering those strategic projects, and maybe also even a role in developing some approach on whether strategic stockpiling makes sense, and if so, at which level, company, member state, or the European level. So we probably will not get to a European JOGMEC, but we do need something. And the concept that we're road testing at the moment is some kind of an operational network which brings together the best expertise around in Europe. You've got your arrangements up there, your structures, and it's very good. We see also that the French have recently retooled themselves. They've created OFREMI and put Stéphane Bourg, who's probably very well known to you, to run it. But also, on top of that, the French they're plugging together with the Germans, right? So you've got BGM tied in with the OFREMI structure. We see this as the kind of like first binary link in what we need to scale up at European level, right? So we like all the best national government expertise, but we also want the best industrial and financial expertise to make this thing really, really happen. So that's interesting. What I also took away is that also very welcome that you're using the UN framework classification as a way to really make sure that you're looking at the different dimensions of the resources, not just the financial and technical side, but the societal acceptance and permitting aspect as well. And also that you intend to extend this to the secondary raw materials. This is all very good. It ties in very much with the work that my team, Robert Thomas and Gerardo Herrera, are running in my team at the moment with you all, trying to develop a good European database of what is there as potential resources and reserves. So the whole minerals intelligence thing, I think, is great, making the point that exploration needs to be systematic. We want to make sure that one of the building blocks in our Critical Raw Materials Act is about encouraging member states, if not requiring member states, to be much more systematic and regular in developing this geological knowledge, because this is what secures our future. This is what we need to make sure we know about, and we need to look deeper, and we need to look at things which today are not necessarily the 30 critical raw materials, because who knows what raw materials may become the real things we need in the future. 20, 30 years ago, lithium wasn't used for batteries, it was used for a range of much less sexy things. So things change, and they can change quite fast. I also like what I heard about helping to develop low impact process design. What we are going to try and do through the Critical Raw Materials Act is really push very hard on the circularity and resource efficiency front. And we have to make it very, very factually true that if we want to make a case for developing more assets across the value chain here in Europe, that it's done to the best possible standards that exist, and that we're always looking for the cutting edge ways to improve even further. So that's really all I would say at this stage by way of reaction to the two interventions that I've heard. And just a reminder that our public consultation on the Critical Raw Materials Act is still running until the 25th of November, and that we already had a very interesting dedicated session with the Raw Materials Supply Group a couple of weeks ago, where we talked you through the upcoming criticality and foresight updates, as well as inviting you to comment to us on questionnaires around permitting and strategic stockpiling. Thank you very much.
Thank you, Peter. I hope you can stay for the discussion part, because I think the Critical Raw Materials Act is one of the things that might cause some questions and interest at least. So thank you, but now we are moving along, and next guest speaker is Jukka Leskelä. He's a managing director of Finnish Energy. Finnish Energy is a branch organization for industrial and labor market policy of the energy sector in Finland. It represents companies that produce, distribute and sell electricity, gas, district heat and district cooling and related services. So please, Jukka Leskelä, floor is yours.
Thank you so much, Saku. Great thanks for inviting me here in this very interesting morning webinar. I try to comment the Simon's work and the messages and the raw material issue from the energy system change point of view and describe a little what's happening in the energy system and why. First of all, there is a huge need to change our energy system, of course. We are currently running the system with fossil fuels. Like Simon said, it's well more than 80% of the primary energy that comes from fossil fuels globally. And we have seen that this huge amount of using fossils is spoiling our atmosphere and environment and causing huge losses in biodiversity and so on. So we really need to do something for that. But moreover, these fossil fuel resources, many of them are located in countries that are not working very much according to the ethical or moral principles that we have in Europe, and that has been seen with the Russian aggression in Ukraine and these terrible things. So we have all reasons to try to get rid of using fossil fuels. What we heard today is that yes, indeed, it is a huge change, and there is a worry that we are causing new challenges while doing this. There is a worry that if this change is happening very quickly, we cannot ramp up raw materials and all value chains needed for that change. I have a little bit of other problem. I consider that this is happening way too slowly. Actually, we are not doing very well globally at the moment. Unfortunately, it seems that the share of fossil fuels will remain very high for a very long time, which is of course something that we should do something and speed up, and hopefully both the policy processes and technological and economic processes will speed this up. But this is not going to happen overnight, and so there is also time to react, and that is needed. While we are trying to end the coal age and the oil age and do something about that, it's not just changing the primary energy and considering that the energy system will otherwise be very similar than we used to have. This is a system change, and the whole energy system will probably look quite different from what we have today. And this is something that we start to learn about and understand more when the change happens according the investments that are being made. At least now it looks like electrification is the key for phasing out fossil fuels. First, in power and heat generation, that is relatively straightforward, and there are huge opportunities to phase out coal and especially coal use in power and heat generation. Happily, this is also happening, but not fast enough. Electricity can be generated with many ways without fossil fuels. Secondly, the big challenge is in phasing out the fossil fuels in energy use, in transport, especially in industry, in agriculture, in machinery, and in all places that fossil fuels are still largely used. And as Simon well presented, that is really changing the whole picture. We need a lot of more power generation if we want to either to electrify the use or generate hydrogen to phase out the fossil fuels. Yes, there is a need for huge increase in power generation globally, and I agree this very much. The third step in this triple jump, first generation, then the energy use, and they are the first two steps, and the third jump in this triple jump is how in the earth are we going to make this new system work. Simon said that he doesn't know how to balance the system. I must say that if someone states that he knows how this power system will be balanced, he doesn't know very much about the issue. We will have a huge challenges in that. We know many things what we need in balancing the power system when we have a huge amount of solar and wind in the system, and the whole electricity system energy system is more or less electrified, and we still have the fact that power system should be balanced every second. Not it is the power system itself. The grid itself is not a storage of energy. What we need know about that is of course that sometimes there is huge amount of electricity available, and we need flexible use of that electricity. We need also some and there will be some transformation of electricity to other energies for gases, for heat, and these can be stored. To create again electricity from these is another story. Then we lose a lot of energy, as Simon well stated, and but still the flexible use of energy is part of the solution. We also need large markets. We don't need to have battery for each wind power station. We need to have energy storage, but the storage needed is much smaller if we have a large system and well-functioning markets. We need price signals for customers to understand when the energy is not available and when it's available, and the energy use will react accordingly. So we know this kind of instruments, and we need, but we also need capacity when there is no wind or solar available, or at least not enough available. And these power stations can be, of course, hydropower stations and so on, but we need something more. And it may be that for some time we need to run also them with fossil fuels, at least globally. So the system is not changing totally renewable, at least not very soon. Happily, most of the change can be done so that we can hopefully save our planet with this system change. How I see what should we do now is of course the question. We know that there is a challenge. There is a challenge in power system, and there is of course the today's theme is how much we are needing raw materials and how to have these raw materials in the system. First, I'm very happy to hear that the European Commission has taken this seriously, because at least I have the feeling as a representative of energy industry that we have looked very carefully on the energy generation and the change there. We have started to look the fact that the energy use should be changed. We are in early stages at that still, European wide, and but actually we haven't been thinking much in between the generation and use and before generation, where the energy comes and where the materials come. So we lack a bit of value chain thinking, and now I'm very happy to hear that there starts to be such a thing. And of course, now when the world is again dividing, we have trusted that there are always liquid markets where we can buy anything. And now we understand that, okay, we are maybe not, everything is maybe not available all the time, and globally the political system is not always in a very good balance, so that we could have raw materials from all countries. So it is very vital that European Union will start to consider the value chains of materials and the whole energy industry. That's the first thing. The second thing is that we of course need the circular economy. Happily, metals can be circulated, but this needs to be developed. We don't have that yet. Thirdly, we need a huge amount of flexibility. I would say that if we need such amount of batteries as Simon described, we have failed. Simply, the power system is failing if we need so much batteries for keeping up the power system. We need to find flexibility somewhere else. And I'm quite confident that we can do significant amount of that with other flexible ways. But that needs to be developed as well. Yes, and we need mines. We need new mining and we need a lot of materials. And it is very important that the leaders start to talk about this, because otherwise we will not have the acceptance for this. So this is part of the solution. It's not a problem itself. Of course, mines are not liked, not at least in anyone's backyard, but they need to be somewhere, and we need the materials, and this is simply a fact. What else? We need a lot of R&D, and certainly it pays off. It is very important that we have funding for developing the energy system together with the raw materials and all that is needed. And still, I really hope that the persons who model the energy systems, who are very deep in who are very deep in energy markets, talk together and sit together with the people like Simon who model carefully the raw materials and also run their view of the energy system development. It's highly important that we gather the knowledge, we learn together, so that we can build something together, instead of like now a little bit happened in Finland, that Simon's work was criticized, and it doesn't help if it goes over the media. We need to have seminars and common R&D projects in order to deepen the understanding and solving the problem, instead of making the problems even worse. So thank you very much. I'm very interested in taking part also to the discussion.
All right, thank you, Jukka, and we are happy to have you in the discussion part as well. And now we're actually moving into the discussion. We have plenty of questions coming from the audience, but I need to start with one of the questions that I identified from the Twitter. So Simon, I guess you're online there. So are we really running out of minerals? I guess when the metal prices go up, so you have more resources. So what is the problem there? Can you elaborate a bit on that?
We are not running out of minerals, and we'll never run out of minerals. The entire Andes mountain range is one big gigantic copper deposit that's really low grade. What is happening is our ability to extract metals out of the ground in a viable way is becoming more of a problem. So costs of production are going up. We're mining out all the good deposits first, all the high grade stuff that's really easy to access and extract. That was all extracted about a century ago, and now we've got these really massive low-grade deposits, and energy consumption to do so is increasing on multiple fronts at the same time. So the current mining system is intimately dependent on fossil fuels. How we might mine without fossil fuels still is not clear. We've got some parts in place, but certainly not all. So our ability to access minerals, this is the difference between what is a resource and what is a reserve. And yes, there are things like market conditions. Now, if the price goes up, that makes it more worthwhile to go after higher cost production. And that is actually the neoclassical market forces model. The problem we are facing, though, is the practical restraints of actually extracting those metals from these low-grade resources require energy. And our energy availability to do so might become a problem and will make a lot of these low-grade mines very difficult to actually deploy, especially when fossil fuel systems are taken offline and whatever replacements we bring online. So we're not running out of minerals, we are running out of our ability to access those minerals. And that is the same across all mineral sectors and components.
All right, and how about China and geopolitics?
So China at the moment controls a vast amount of the value chain. Because mining is not considered fashionable or acceptable in Europe, we don't do much mining here. So we buy things off the market. And we tend to buy finished products that are made in China. China has decided it wants to be an industrial superpower, and it will actually consent to mining its own territory. So China will control most of the smelting and refining. In Australia, we do a lot of mining, but we don't do our own refining. We sell it to Chinese smelters. So the Chinese, because they have consented to do this, they've consented to go and do work that the rest of us don't want to do, now control about 60 to 70% of the global industrial value chain, and their long-term goals are to control more of it. And so at the moment, they absolutely dominate the commodity sector.
Yeah, that's correct. Then another question that revolves around the sensitivity of your analysis. And there's a lot of variables and a lot of assumptions. So would you care to shed a little bit light on this topic as well?
So this was a really difficult topic to get my arms around. There were so many things that didn't exist or hadn't been developed yet. And so you have to make assumptions along the way. And all people who make these studies make assumptions, right? And those assumptions don't match reality later because they are assumptions. So the first assumption for me was the hydrogen economy actually will work. We are able to make such a large volume of hydrogen, store it and transport it. And there are logistical bottlenecks there. If we can't make the hydrogen economy work, we've got to fall back on something else. And electric vehicle systems are relatively stable at the moment, and we know how to do that. That bottleneck is, well, are we able to produce the resources needed? That's another assumption. Now, then there comes to the power storage system. Obviously, wind and solar needed some kind of buffer. And for a long time, I could not get a straight answer out of anyone about what that actually would be or why. And a lot of the answers that did come out about that weren't able to address some fundamental physical engineering requirements. And so it was a very, very colloquial environment, if you will. Lots of things were very vague. And so I required precise answers from that vague colloquial environment. So assumptions were made. And there's a whole series of them, and that whole network then hangs together. And there's lots of things missed in the study as well. Like the amount of fossil fuels used in, say, the heat of manufacture and industry is just not looked at all. I just didn't have the time or the capacity. The amount of metal that will be required to, for example, to build the transmission lines that will then have to sort of spread, and all the new infrastructure and charging stations, or the infrastructure around the hydrogen economy. None of that was actually looked at. So yes, assumptions were made, and yes, things are missing.
Yeah, one of the missing things was probably the per capita use of materials or energy at global level as well.
To do that, though, requires a substantial piece of work. There's something work we could do in the future, but that requires a substantial amount of data collection and analysis to actually hit those targets in a credible form.
Yeah. And then I think one of the hot topics in the questions is the nuclear power, and one of the comments was that there's a small material footprint. And so, any thoughts on the role of the nuclear?
I'm a fan of nuclear. I like nuclear, but I did a simulation of what would happen if we got behind the nuclear industry, and can it expand fast enough to be useful? So one of the, you might notice in the report too, I used Generation 2 as one of the simulations. I actually heard a European Commission official saying all nuclear power plants going forward should be Generation 2 because they're cheaper to build. And that really surprised me. And so, all right, okay. So that was the first simulation. But what would happen if we all got behind the nuclear power plant industry? We built out all the infrastructure that's supporting it, because it's a very complex value chain. It's very expensive. You know, we've got to enrich, we've got to not only mine uranium, but enrich it into uranium UF6, uranium hexafluoride. And then you've got to make fuel rod assemblies. And then you've got to get it into the power plant, and then you've got to get it out, and then you've got to manage the spent nuclear fuel. So you need a whole lot of infrastructure around each power plant for it to run properly. So let's say it took only 5 years to build a nuclear power plant, as opposed to what we're doing at the moment, 5 years. And let's say we expanded the fleet. We're about 441 power plants at the moment, and including replacing decommissioning, a net extra 25 nuclear power plants a year, every year from the year 2025 onwards. Right? Could the power plant fleet actually expand fast enough to be useful? The answer is no, because nuclear has got to expand to take over fossil fuels to start with, but then we've actually got to account for the extra power to phase fossil fuels out and do the electrification. And after about 70 years of expansion at that rate, you get about 60% of the way there. So the nuclear power plant fleet can't expand fast enough to actually replace fossil fuels in time. Now, the Achilles heel for nuclear in its current form is, how do we manage the massive stockpile of spent nuclear fuel coming off these reactors? And there's different kinds of spent nuclear fuel, and there's different kinds of facilities to store them in, but we've got to build those facilities. And at the moment, that's not done very well, if at all. And another problem.
In Finland.
Yes, but only in Finland. Right, like, well, see, everyone else is just putting their fuel in these power-cooled storage cooling pools. And you're supposed to put your fuel in the cooling pools for a couple of years. It's 10 years is the market, but some of it's as little as 2 or 3 for some kinds of nuclear fuel. But if you've got so many of these systems, and you've got so much spent nuclear fuel coming out, you're having to spend a lot of power to cool them, and you've got to keep cooling them for a number of years. If we get to the point where uranium runs out, that's not going to happen. right? But let's say we get to the point where we stop the nuclear system. For a couple of years after that, we've got this massive power draw to manage the environmental requirements of managing the spent nuclear fuel pile. So what I'm getting at here is a logistical scale-up bottleneck for the nuclear fuel cycle. That's going to be the problem.
Yeah, and of course we're aware of that. There's a lot of other disposal site projects, sorry, in the world, and they're ramping up. But I have one question to Jukka from the audience. Do you see a role for purple/red hydrogen? It seems that like Japan is going for this in a big way.
Well, it's a bit difficult question for me. I once calculated that there were 8 or 9 different colors of hydrogen in so, yeah. and this yes, I would say that this is a little bit similar than the nuclear issue, the hydrogen issue. That technically there are ways to build the system, and then it is the question of the economics and because the development of different technological lines needs huge amount of money to put in. So then sometimes it even the ideas that sound quite good don't start. But yes, I see that at this stage, it seems that hydrogen will be made with electricity, and that is the main line. But certainly, I'm more than happy if there will be other kind of hydrogen available.
So you mentioned that we need a lot of R&D. So probably this is part of that. And would there be any other topics of R&D that would be, let's say, priority from your point of view?
Well, we need a lot. One area is the system stability and the how to how to run the energy system optimally, and the energy system is not anymore that we have separate system for transport, separate system for industry, separate system for heating, and separate for electricity. No, they need to be combined, and that area is something where the efficiency is hiding, and the solution for the flexibility is hiding, and we need to find these resources, hidden resources in the system. And at the same time, we know that if we change the form of energy many times, we are losing a lot of energy. So that is, we are sometimes proposed very much of storing huge amount of hydrogen and generating electricity again. That I see that it's quite inefficient actually. So we need other kinds of flexible systems. Yeah. But we also need to understand that the power system cannot only run with wind and solar. We need other kinds of generation there in the system. And happily, in Nordic countries and in Finland, we have different kind of resources available, but they are not located in all countries. Hydro, bio, and we have nuclear, and we can still develop that. We need that, and what else is needed a lot is grids, and the grid infrastructure is something that is a little bit forgotten area of the energy transition. Some people considered when we get to the distributed generation, we need less grids, but now everybody understands that we need much more grids. Not only power grids, but also heating and gas grids.
Yeah. Thank you. And I'm just wondering whether Peter is still here among us. I have one question for Peter. It's about Critical Raw Materials Act, and any ideas what is the timeline for that, and would you have anything to tell us at this point?
Yes, well, we're instructed to have this ready for adoption by the end of March next year. We're also instructed to make sure that there's an impact assessment which has to be ready by the 13th of December. So it's a lot of work, and this is why we're encouraging anybody who intends to respond to our public consultation to do so ahead of the deadline, because if you imagine on the 25th or the 26th, we're going to be able to process all that input within a week or so. It's just a very tall order. So yeah, the timing of this is because we don't have that much time left before the end of this Commission or European Parliament's mandate, right? So it's only the start of the process when the Commission tables a proposal. We need at least a year to get this through the co-decision.
Yeah, thank you. And what would be the relationship between the Mineral Security Partnership that the US has been very active on, and so anything on that front?
Well, that's not really linked to our future Critical Raw Materials Act, because that's it's a thing that's already happening. Just in the same way that we have been launching a series of strategic partnerships for ourselves since our 2020 Critical Raw Materials Action Plan. The Mineral Security Partnership is a plurilateral exercise, so launched by the US State Department. Well, the idea was launched in March this year, and the partnership itself was launched in June. We sat there originally as European Commission alongside Finland, Germany, Sweden, and France, but we've since obtained the Council's approval that we're there now as European Union, so we can really make use of it. Everyone's trying to understand really what it's all about. Everyone's pitched in a list of projects. The Japanese, for example, put in 90 projects around the world. The Canadians put in about 70, mostly in Canada. The Australians put in projects mostly in Australia. We in agreement with the 4 member states, we tabled proposals in Africa and Latin America, because we think that we need to focus initially on our own resources here in the EU 27 and try and get them off the ground ourselves if we want to benefit from the materials that we'll be helping to invest in their development. So we're focusing through the Mineral Security Partnership on goodwill cooperation and sharing the risk, sharing the benefits of projects in places like I don't know, Angola or Tanzania or whatever it might be. But what we've seen already in the very short time since this partnership is launched is that we have to move fast. Just in the last couple of months, projects which we considered to be, very, very useful for the West have been acquired by Chinese mining and battery producers under our noses, right? And the whole purpose of the Mineral Security Partnership is actually to try and make sure that the West and like-minded countries secure the resources they need for their green and digital transitions, as well as for their security needs.
Yeah, thank you. And one of the questions from the audience was that for Simon, that how much we should reduce the consumption so in order to be successful in transition.
That's actually a very interesting question. I actually don't have a solid answer for that, because we consume such a lot of resources without really realizing it. We're a very wasteful society in what we consume and how we manage our resources. I think if we have a social contract change where we go to a relationship with energy and minerals similar to the relationship we have with money, things will change very quickly. How much to reduce by? Like, I did a simulation for Finland. Like, what would Finland require to phase out fossil fuels across 6 scenarios? And one of them, the recommendation in the end was a 50% reduction in consumption. But I actually don't know what the true answer really is, because we actually don't know what the true limitation boundary conditions are yet. have yet to do the proper thermodynamic or industrial entropy calculations to actually say what will our society actually look like when fossil fuels are knocked out and we put in their replacements.
Yeah.
I would suggest it's more than we think.
Okay, fair enough. And how would you describe the net position of Finland in this context?
Interesting. Right. Before I get to that, Peter, have a look at the Chinese have a plan, Made in China 2025. Europe has its circular economy, and the Americans talk about the steady state economy. The Chinese have a plan, and it's been in action since the year 2003, and it's well in advance because they're financing it, right? And what you described there is their plan. Yes. Anyway, so the Nordic frontier is actually in a remarkably different position to the rest of the world. There's a lot of non-fossil fuel power systems here that don't exist elsewhere. Like Finland's got nuclear, but we've got a massive natural environment with a viable fleet of combined heat and power that can harvest wood from that. And so we can run heavy industry as it stands now without any fossil fuels intervention at all. Right, Norway has lots of hydro, but they also have lots of oil and gas. They can keep us alive while we make the new system. Denmark's got oil and gas. Iceland has got so much geothermal they can make aluminium. So I think the future is going to be an industrial alliance between industrial clusters across the Nordic frontier. Finland, Sweden, Norway, Denmark, Iceland, Greenland will preferentially do business with each other. Finland in particular, 80% of our electricity is non-fossil fuel as it stands now. That's amazing. We've got a small population that's highly educated in a massive, pristine environment, right? And we've got lots of industrial capability that's already off fossil fuels. It's entirely possible that Finland will get itself organized before many other nations. So we could well become an example and a starting seed to create other things. We have our vulnerabilities, we have our challenges, but our net position is actually much stronger than many other nations.
Yeah, thank you. And then another question from the audience says that, Simon, if you see the renewables are only a step to something new, what that would be, hydrogen or something else?
Yeah, well, that's an interesting question. All the things that we think we're going to use have their logistical bottlenecks, and they're not going to they're not as calorifically dense in terms of energy. All energy systems have to recognize the fact that that energy has to come from somewhere. And all existing systems are not as calorifically dense as what we've used to make the last industrial system over the last century or so. I think we're going to go into all of these renewable systems, and that's what we're going to do. But while we're doing that, we will consider unorthodox ideas in ways that we haven't before, or ideas that we have considered before but rejected because they're too unorthodox or just too hard. We might look at them with new eyes. And I think humanity will surprise us. And I do actually have some ideas of what that might be, but it's really unorthodox. And I think we're going to go back to the primary sciences. Now, this may sound a little strange. What we need is something that actually changes our viewpoint of energy and how we harvest it. We might have to see what energy actually is differently. And the way we might be forced into doing that is to developing an industry that forces us to do that. Now, I sat in on a number of seminars about the space industry, getting a civilian workforce up into orbit. For us to actually do that, well, first we've got to find the energy to do that. But for us to actually do that, to operate in that environment with civilian workforce, we're going to have to re-examine all our fundamental science. And I think in that environment is ripe for a breakthrough. Because I'm of the opinion that what we call energy and our fundamental physical understanding of it is still only halfway there. And okay, I can see an innovation in that direction. But that, if it works, that's like decades away. In the meantime, it's going to be solar panels, hydrogen, and all the things that this panel is discussing.
Yeah, and then actually following on that, so what is the role of carbon storaging? So, is that part of the solution?
That's part of a solution, right? But it's not part of the power solution.
Yeah.
Right. We've got to deliver power to the grid for industrial purposes for society to use power, right? The idea of carbon capture is to offset carbon consumption, right? So we've got a number of problems. We've got a number of macro scale problems that have landed on our plate all at the same time. So the carbon capture idea is to mitigate the risk of climate change. And I'm not entirely convinced it's going to work, incidentally. I can see it conceptually, but I've yet to actually sort of see it engineering at a pilot scale yet. But the delivery of power to an industrial society and the society it supports, right? That's our primary task. Whether we use carbon capture or not doesn't address the logistics of that. So to me, the reason I've actually stayed out of, when I've written my reports, I've not used market price and I've not used carbon emissions. And the reason I've done that is I've tried to go on straight for the physical footprint, the material flows of what's required for us to function.
Yeah. Okay, thank you. And then another point of view from the audience is that what is the role of public sector and international collaboration in your scenarios or in energy transition? Are the markets able to handle the transition by itself? This can go to Jukka and every one of you.
Okay, if I may start, first of all, the change will never happen if we count on governments to finance it. So we need to have private investment, and that's running the change. And the question is how to more or less invite the private sector to do the change. Yes, politics is needed, and we need to have a lot of international cooperation in the politics. We need climate policy, but we need a lot of cooperation in generating the technologies and spreading them and so on. But first of all, we need efficient markets and global markets, and we need to develop the markets so that that the system is investable for private money.
Okay, Peter, please.
No, I totally agree with that, but I think it's very important that governments, as individual governments or as the European Union or as like-minded countries around the world, they set a long-term destination, which is not going to fall apart each time there's a change in the political cycle, right? That's why it's important that Europe's actually given itself a legal obligation to achieve climate neutrality by 2050. We don't have all the answers how to get there, and some of the more rigorous actions needed in 5, 10, 15 years, well, we don't know what they're going to be yet, but we do have that degree of predictability. Where it falls a little bit short in terms of the environment signals, the signals that we give to business is when we propose a package of measures to achieve climate goals, and then just before we start to implement them, we change and ramp up the level of ambition. We've done that, right? We've done that with I was involved in the last mandate on the energy and climate work for Energy Union, and then this commission came in with the Green Deal and Fit for 55, and then because of all the stresses and supply chain disruptions and whatnot, we ramped it up again this year in the Repower EU. So it's a moving target, but the destination is always the same. It's just that sometimes you need to move faster, sometimes you need to move a little bit sideways, as we're doing at the moment, where we've got a certain amount of tolerance for looking for fossil fuels just to keep the lights on this winter, But we really do need to give that direction of travel so that investment can take place, and it's not going to be funded by the public sector. Public sector can come in with a bit of strategic de-risking and make sure that the financial tools are in place, but the markets are going to have to learn how to do this.
Okay, thank you. I think we are soon running out of time, but I would like to address one point. Like Jukka said, that it's perhaps not just a question about the phasing out of fossil fuels, but the future energy system will be different from what we have now. So I would like to have each of your comments on that. How does the energy system will be in the future, or the future outlook of energy system? So any comments on that?
I think I'm a little bit responsible to start with, because I stated that, yes, it's first of all, our energy system has been one directional. So from generation, from coal mine to the generation, and there we have distributed electricity, or we have drilled oil and developed fuel, and then it has been distributed to customers. Now that has already changed, and it's changing rapidly. That the customers are investing in the system. So each household and each SME has their own energy system soon. They generate electricity, they store electricity, at least in their EVs. They generate heat with the heat pumps. They store heat in the warm heat tanks or boilers, and yet they still sell electricity and they buy it, and they still buy heat. So they have their own energy systems, and these energy systems need to be optimized for the customers. That's one huge business area to be developed. And the second is the interface of these small energy systems to the centralized system, and that's another huge area to develop. And there we will find new innovations and use digitalization to be efficient and find the flexibility. And another issue is that sometimes we have huge amount of cheap electricity available, and certainly there will be developing industries and all kind of uses for this electricity, this is not the problematic side. The problematic side is that do we have always enough of capacity, and that is something that may remind the system that we have now, but we will have a lot of new kind of use for electricity in future.
Okay, thank you. Peter, perhaps any comment on this energy future?
I really don't feel qualified to say what it's going to look like in 15, 20 years time. We've really done our best to design how to get to 2030 with the full range of renewable and energy storage technologies, a real big push to decarbonize energy intensive industries, and to really go as far as we can on efficient processes, so we actually can try to use less energy. So I think Simon's point is very valid. I mean, we maybe need to find our way to design a low energy future, right, and still have all the benefits that we need to have as society. But I think trying to design that for off planet is a good test of how to really rethink the fundamentals.
Okay, thank you, Simon. We have to close this soon, so just if you want to have a comment, and then I'll wrap this up.
Okay, so I think the future energy systems will be simpler. They'll be less complex. They'll probably be smaller, and they'll be tasked to do applications that have been thought through very carefully. Like, do we really need this application? Right across the industrial ecosystem globally, it will be less quantity but higher quality actions on all fronts, and that will be reflected in design. Our technology will be able to handle, I believe, variable power supply that's not necessarily as clean as it is now, so it'll be able to handle power spikes and blackouts and brownouts more easily. That's the simple answer.